Hello everyone, welcome back to the AWS Cloud Engineer Essential series. My name is Dheeraj and today we are going to cover the essentials of Amazon DynamoDB. So in this video, we are going to explore DynamoDB, which is also known as AWS Fully Managed NoSQL Database. You will learn what DynamoDB is, how it differs from RDS, key concepts like tables, items, and primary keys, and we will finish with a quick hands-on demo creating and querying a table right from the AWS console for you. So let's get started by understanding what exactly is Amazon DynamoDB. So it is a NoSQL database service from AWS, meaning it stores data in flexible formats instead of traditional rows and columns you can see in a relational database that we saw in our last video, that was Amazon RDS. It's a fully managed service like RDS, which means you don't have to worry about setting up servers, managing infrastructures, or handling backups. AWS does all that for you automatically. DynamoDB is built for massive scale. It can handle millions of records per second without any manual tuning. When it comes to performance, DynamoDB consistently delivers single-digit millisecond response times, even at high traffic levels. That is really amazing. It's commonly used for mobile apps, gaming leaderboards, IoT data storage, shopping carts, and session management. Basically, any use case that needs fast, scalable, and flexible data access. Now let's compare DynamoDB and Amazon RDS to understand when to use each one. So we use DynamoDB when you expect high traffic, need a flexible schema, or work with key value access patterns. It's ideal for use cases where speed and scalability matters more than complex querying. Use RDS when your application requires complex SQL queries, join operations, or transactions that ensure data consistency, like in traditional relational databases. The key advantage of DynamoDB are automatic scaling, predictive high performance, and no schema migrations, since data structures can evolve easily. On the other hand, RDS offers powerful SQL querying, relationship between tables, and full ACID transaction support, making it reliable for structured data. To make it simple, think of DynamoDB for user profiles, gaming apps, or IoT data, and RDS for banking systems, ERP platforms, or any app that depends on complex transactions. So let's understand some key concepts that make up the structure of DynamoDB. First key concept is tables. So these are the containers for your data, similar to tables in relational database. But unlike RDS, DynamoDB tables have flexible schema, meaning each record can have different attributes. Let me tell you in simple words, when we create a table in relational database, that is RDS, so in that, whenever we have to create the records, okay, that is rows, so it's compulsory for us to give value of each of the columns for that specific table that is created. But in DynamoDB, it's not like that, it's flexible. Items, the next one. So these are the individual records stored inside a table. You can think of them like rows in a traditional databases, but with the freedom to store varying sets of attributes per item. Now comes the attributes. So these are actual pieces of data within each item. They are stored as key value pairs and can have flexible data types like strings, number, list, or even nested maps. So let me explain you. So first we create a table. So table name is product catalog. Then we create an item. What is the item? Item is item where we define the primary key and we define the sort key. Then when we create, so attributes are the row entries, the insert operations that we do. And finally, the primary key. This is the unique identifier for each item in the table. It can be defined as a partition key. So in DynamoDB, you will hear more of partition key instead of talking about primary key. It's a single attribute or a combination of primary key and sort key, which allows sorting and efficient querying of related data. Together, these elements make DynamoDB both simple and highly flexible for managing modern application data. Now let's talk more about primary keys, which is the heart of DynamoDB. So the partition key, often called the primary key, is a single attribute that uniquely identifies each item. It also determines how data is physically distributed across DynamoDB's internal partitions. You can also use composite key, which combines partition key along with a sort key. This design allows you to group related data together and perform more flexible queries within the same partition. Choosing the right primary key is extremely important because it affects query speed, latency, and how evenly data gets distributed. Always aim for high cardinality partition keys, meaning they should have a wide range of unique values to prevent hot partition and ensure balanced performance. For example, in an e-commerce application, using customer ID as partition key and order ID as the sort key makes it easy to quickly retrieve all the records placed by a specific customer. Now, let's talk about DynamoDB features. So, DynamoDB is designed for both highly scalable and extremely flexible environments, making it one of the most powerful NoSQL database offered by AWS. It supports two capacity modes. The first one is on demand, where DynamoDB automatically adjusts the capacity based on the traffic. That I will show you. And you can pay only for what you use. And in provision, you define the read and write capacity units to control cost and performance for predictable workloads. So where you already know that what kind of capacity, or if you have any capacity constraint, you can define it by yourself. Next comes DynamoDB offers secondary indexes that we just spoke about, which allow you to query your data in ways other than the primary key. So there are two types: global secondary indexes, that is GSI, which let you query across the entire table using different attributes, and local secondary indexes, which let you create alternate sort keys for more flexible queries within a partition. I know it's a bit complex, but when we are going to create the DynamoDB table at that time, I will show you while creation, they will give you an option while we are going with default settings. In that, it shows a table which will show you that what is this global secondary index, what is this local secondary index, and if you want some custom settings, how you can do it. We will talk about that in the hands-on lab. Another key feature is DynamoDB streams. They capture real-time changes to your data, enabling event-driven workflows or integrations like Lambda triggers for reactive application. For example, suppose if there is any item, so at every insertion of an item in the table, we should go ahead and send a notification. So suppose if a new product, that is a new laptop inventory, has came in, okay, and its entry has been added to our table. So as soon as an entry of new laptop is been added, I would like to get notified because I have to order those laptops for my specific warehouse accordingly. So in that case, you can use DynamoDB streams, where an event will occur when an item is added to the table, and based on that event, it is been captured, and you can trigger a Lambda function to perform operation for yourself. And finally, global tables make it possible to replicate data across multiple AWS regions automatically. This ensures low latency, high availability, and conflict-free updates for global distributed application. Now, let's understand the capacity mode pricing models. So first is the on-demand mode. This is the simplest option. You pay per request without needing to plan capacity in advance. It automatically scales with your traffic, making it perfect for beginners or workload with unpredictable usage patterns. The second option is provision mode. Here, you predefined how many reads and write your application is going to perform per second. It's ideally for steady workloads and offer lower cost at scale once you understand your traffic pattern. So for example, suppose you are going to go ahead and it's a greenfield project, which means that you don't know what kind of load you're going to get for a specific application you are building. So in that case, what we usually do is we go ahead and we use on demand. And then once it is on demand, then we monitor that by using monitoring solutions for 1 month or 2 months to understand how traffic comes in and what is the load. Based on that, later you can go ahead and you can use the provision mode so that you can lower your cost. To measure this capacity, DynamoDB uses two key units. One is read capacity unit and the other one is write capacity unit. So read capacity unit, one strongly consistent read per second for items up to 4 KB in size, and write capacity units is one write per second for item up to 1 KB in size. So read capacity, remember, it is for 4 KB in size and write capacity is for 1 KB in size. So in short, you can choose on-demand mode for flexibility and unpredictable workloads, as I just gave an example, and provision mode when your traffic is consistent and you want better cost control. Now, too much of talking. It's time for hands-on. So now what first I'm going to do is I'm going to take you to DynamoDB console. We are going to create a table. Inside the table, we are going to create a product catalog as I just discussed and a product ID. Once we do that, I will show you the options of indexes that I was talking about. So I will jump on the AWS console. You have to go and search for DynamoDB. Once it is here, just open this. Once I have opened the DynamoDB, I will go to dashboard, create table, and here is the table name for us. So let's give the table name as product catalog. So this is our table name. Now the partition key that I want to give over here is going to be product ID. So now when you're going to create your partition key, it is upon you which kind of data type you want to have for your partition key. It can be binary, it can be number, it can be string. For now, I am keeping this as string. And I was speaking to you guys about default settings and customized settings. So when you click on default settings, by default, it is off on demand mode. See, capacity mode is on demand. So over here, a maximum write capacity, read capacity, you don't have to mention, right? And these are the other options that I was speaking about, that is local secondary indexes, global secondary indexes, and you can also enable deletion protection as well as you can add resource-based policy. So these are advanced concept which we are not going to do, but let's have a look by clicking on customize setting. Once you come inside, then you can select the table class, whether it should be standard, which is the general purpose table class, and otherwise it should be standard IA. Okay, so you can select from any of them. Then over here you can go ahead and select your capacity mode, on demand or provision. So suppose if you want to do it on in provision, and over here you are confused what kind of provision capacity I should give and how I should define it. So in that case, they have given you a capacity calculator. So over here you can see that the average item size, the size of an item. So you can give over here. So the read, write, and based on that, it is going to give you like you have to select whether it is going to be eventual, consistent, strongly, or transactional, and then automatically it is going to show you the estimated cost. So in that way you can calculate whether with your customized provisioned approach are you going to save money or not. Now warm throughput, this is an advanced concept that we have not spoke about, and encryption at rest. You can enable encryption at rest by using these three options, that is where you can have your own key, AWS managed key or customer managed key, and you can have a resource based policy defined also for your specific table. Now I'm going to go ahead and click on default settings, and I will be clicking on create table. This is going to go ahead and create my table. Once it creates my table, at that time I will click on explore items, and this is here our table is created. So once our table is created, what we are going to do is we are now going to insert an item, add an attribute, and query the items that we have added as part of that specific table. So let's go ahead and click on product table, product catalog, and right now you see there is no item available. I will click on create item. So product ID over here, I can say 102. And right now you will see that we only have primary key. What about other things? So it can be, you can go ahead and add from here. That is the new attributes. So for this product key, the uh, category I would say is going to be, you can select the data type first and then you can give the attribute name. I will give the attribute name as category. Okay, and I will give the value as books. This is one attribute that you have added inside and table. So inside this item, you have one item have multiple attributes. So this is item and you are adding attribute for that specific item. Now I will add one more string that is going to be name. It is going to be the name of the product. So I would say AWS DynamoDB guide. Let's add one more, and this time we will change the data type. I will keep it as a number. So over here I can say the price of the book. So the book price is going to be, let's say 13.99. Okay, and I will click on create item. And that is how your item is created successfully. If I click on your item, now you can see this is your item. And if you click on JSON view, you can see the view of the item that you have created. Okay, so this is what your item is all about. Now, the way you have created your item, this is how it looks in the key value pair in the JSON format. And if you click on this, it is just going to show in the DynamoDB format. What's the difference? I will show you. So this is the JSON. It is saying this is the key, this is the value, key value, key value. Now, if you click on DynamoDB, along with key value, it is also showing you the data type. So this is the first three are strings and the fourth one is number. Now, this is one way of creating your item. Let's go back. Cancel. Now, one item is created. So now we are going to go ahead and create one more item, but this time with some different approach. So in my previous item that I created, I showed you that once you create your item, you can create it from the console, or you can also go ahead and add a JSON over here. Once you add a JSON, automatically it is going to create your record. So over here we have added item 102. So you can also go ahead and create item and click on JSON view, and you can go ahead and add your item over here. But this time I am adding a different item, but let me show you. If you try to use the same primary key, is it going to give you an error? So let me make this as 02, which was our previous, and I'll click on create item, and it says that the primary key already exists. That shows that our product ID is a primary key which is supposed to be unique and it cannot be reused again. So now this time I'm going to click on 103 and I will click on create item, and that creates your second item over here. So that concludes the step of us where we have added the attribute, and now it's time for us to query it. So to query, what you have to do is over here, click on query. Over here it is saying your partition key is product ID. Go to product ID and go ahead and give any of the product ID. So right now let's go ahead and fetch 103, and if I click on run, you will see it will fetch the product over here. So it returned one entry, right? If you have thousands of items over here, if you are going to perform a search, at that time it is going to be useful. But now just for demo purpose, I am showing you how it works, and that shows that how you can perform a query onto the items that you have created within a specific table, that is product catalog that we had created. Now it's time for us to see the best practices. And the best practices are as follow. So when working with DynamoDB, as I said, performance and scalability is the key for which we use it. So the first, use partition key and sort keys wisely. They help organize your data efficiently and give you more flexibility when you are querying related items. For unpredictable workloads, always go with on-demand mode so your database can automatically scale without any manual intervention. For predictable workloads, once you understand the pattern that how much is going to be your workload, go ahead and choose provision mode to control cost and maintain consistent performance. Remember, DynamoDB is a NoSQL database, so your tables around access patterns, uh, not traditional relational joins. That means start by identifying how your application will query the data, then structure your table to support those queries efficiently. In short, always design for how you will query the data, not just how you will store it. That's the key to unlocking the DynamoDB full performance and scalability. And that wraps up our tutorial on Amazon DynamoDB. And remember, DynamoDB is built for speed, scale, and flexibility, making it perfect for modern high performance application. If you find this video helpful, don't forget to like, share, and subscribe for more AWS tutorials every week. Thank you for watching, and I will see you in the next video.